So this video is going to be about frequencies and the freq data type in Zen. To create a certain frequency, we just type a number and then hertz. So now we have 500 hertz. We can also use the function freq, which will take in a number and convert it to hertz. As before with ET and ratio, this function can be used to apply to other things, such as maybe MIDI note number 69, which is 69 steps in 12-tone equal temperament. We want to convert that to frequency, and it'll be exactly 440. And similarly, we can just use the HZ operator, which will take this value, and it'll convert it to hertz. It's worth noting here that in the last videos, I was dealing with ET values that were like 4 steps, which is a relative value, it's an interval. When we work with ET values and cent values and then try to convert them to hertz, it makes more sense to be dealing with absolute values, such as notes. So this is, again, MIDI note 69. This is not an interval from MIDI note 0. I'm thinking of it more as a note. But in this language, ET and cents can either play the role of a note or an interval. If we try to convert something small like number 4 to hertz, it'll be a really small value in hertz. And of course, this value in hertz is not actually an interval. This is a note. So whenever we convert to hertz, we want to actually give in something that looks like a note, so we don't get any sort of crazy values. So with these frequencies, we can add them, and this is actually the one exception to the rule that all addition takes place in pitch space, because we're just adding 10 hertz to 500 hertz, so of course it makes sense to give us 510 hertz. We're actually adding these in frequency space as opposed to pitch space. On the other hand, if we have something like this just major third, and we want to add it to 500 hertz, what that's saying is I have this note 500 hertz, and I want a just major third above it. So it's going to give us 5/4 times 500 hertz. And again, we can do that with equal tempered values. And so these are all situations where the arithmetic is happening in pitch space. But if you have two frequencies, it'll happen in frequency space. One thing I'll mention is that it's not possible to have a negative frequency. For example, we can't say creating a frequency with like -4, because we can't play back negative frequencies, we can't do operations on them, we also can't have a 0 frequency. That's about it for frequencies, and in the next video I'm going to talk about lists.